Good afternoon. Can you hear me? Okay. Thank you for coming for this snowy day. But, I will talk about something about Aurora and then adding a few things. This is the title Ned gave me for my talk. And yeah, I'm sure that they have seen the Aurora mammoths too, but they didn't leave any written record, so we cannot tell, but I'm sure they saw. As you may know, that Aurora is the name of dawn of Roman mythology, but how this term is used for the scientific term is not known. Somebody started to use it, and we don't know who it was. So Roman days, star was just a hole in the sky. Aurora was cracks in the sky and the flames come out. We have many stories, legends by native people, and perhaps you know more than I do. Early days, 16th century, people didn't know what it was, so by their imagination, some people thought that's just a candle in the sky, or fighting in the sky because rays, Aurora, many of you know, rays move around, so they thought maybe war in the sky. But as the time goes, like 19th century, people became pretty accurate. This is a very accurate sketch of the Aurora. This Murtoke, I think, a Danish artist specialized in the Aurora painting. This was sometimes Aurora is very red, and the people were very afraid of something with a ill omen. This is a famous Alaskan artist, Sidney Lawrence. There are many interesting stories about him. Then Arctic explorers and travelers or adventurers start arriving in the Arctic. Actually, Nansen was a very good artist too. So this woodcut, and he has several others, very accurate the painting. Then came all kinds of people, adventurers, wrote a book, came and they talk about the Aurora they saw. And the people start to read this and found that there's an interesting phenomenon in the Arctic. Okay, there are many theories. The Aurora, I would just choose one. Benjamin Franklin, he thought that moisture from equator go up to the north and then fall as a snow. Then snow and the atmosphere have some kind of electrical discharge. So he thought about some electricity is involved. It's interesting to know the history, how people try to record the Aurora. This person sketched, or he has many, many hundreds of sketches of the aurora like this. Then came camera. This Norwegian scientist, sitting one is a famous person, Carl Sturmer. And then around 1930, a professor at University of Alaska, Fuller, did a lot of studies of aurora. And you see the picture there. I had an opportunity to look at a whole bunch of his plate, and that's about the best one. So those days, 30, 40 below, and the operating camera, a very difficult task. Then came all-sky camera, can take a picture of the whole sky, and I'm going to show some all-sky camera pictures. It's a circular. You can take a picture of whole sky. Top part of a circular image is northward, magnetic north. Okay. I believe that former director Elvey and Neil Davis responsible for making this camera. And then at the end of 1972, this is the first image of the aurora taken by satellite. I will come back to this picture later. I will show you, there are many, many theories, modern theories, but I chose two. One is Norwegian scientist Birkeland, and he had thought that electrons were discovered about 10 or 15 years before, so he thought that electron beam is responsible for the aurora. So he made a huge vacuum box and put the iron, the magnetized iron ball, and then shot the electrons, try to reproduce the aurora. It's still, it's in Tromsø University in Norway, and it still works. And Birken wrote a very large report. It's pretty heavy, big book. And then came Sidney Chapman. He is from Oxford University or Cambridge both. And he thought that it's not electrons, but electrons, protons together, what we call now plasma, hit the Earth and the magnetic field. Then he thought that around the Earth, the solar gas blow around the and make the comet-shaped the cavity. So that was 1931. Then after that, about 1960, there was not much progress of the war. So let me go to how I decided to study the aurora. My mother had a favorite song, and singing quite a bit, like, and it's the beginning of the song is, should I go further back, or wandering under the Aurora. So that's, and of course that's when I was young, but my uncle and aunt sang this song for me at the time of the first year anniversary of my mother's death. So my memory is, I think, okay. So that's the first time I heard the word Aurora. As you know, that Earth is a gigantic magnet, and this was discovered by William Gilbert, 1600. But this field is not constant. It changes a few times, percent or 10% at most. So in the world, many countries have observatories to record the changes. And my university has the observatory. It's in a big cave. And there is a machine called magnetometer. And in that machine, there is a little magnet, and the mirror is suspended, and send the light beam to the cylinder, which rotates once a day. And because it's in a cave, the cylinder is wrapped up photographic paper, so it's in the darkness. The only thing I could see is the light spot. And I was really fascinated by delicate movement of those the light spot. So I asked the manager of the observatory, it's Aurora is moving. And so I thought, I didn't know much about science at that time, so there must be a magic hand, such a great distance, move just a small light spot on the paper. So then I was told that nothing much is known yet. And so, okay, I will study the Aurora. So this is the second time I heard the word Aurora. Then, how to study the Aurora? How can I do it? And no one seemed to know what to do. Sometime between 1956 58, I was told that if I'm interested in the Aurora, I have to read Chapman's paper in 1931, and I have to understand the paper. Otherwise, I'm not qualified to study the Aurora. So I went to the library, found the paper. It's very hard. Even now, it's hard. But because I decided to study the Aurora, I had no choice but write to him, put my questions. Then I learned that he's at Oxford University and the top guy in the field. So I kind of hesitated to send anything. Then I learned that 1958, he retired from Oxford and spent a few months at Geophysical Institute. Then I was told also GI is the only institute in the world that specializes in auroral research. So I thought that the right place. And so I wrote to Chapman, so I finally decided to, after a lot of hesitation, send a letter. I didn't expect I get any reply. But surprisingly, a few weeks later, I got a reply, and what he said was, if I'm interested in the aurora and those questions, why don't you come to us study under me? So okay, that's the way I came to Geophysical Institute. At that time, that was dawn of space age. Some of you know Sputnik, and GI is one of the few places received signal from Sputnik. At the time, also 1958, Van Allen discovers radiation belt, donuts-like high-energy belt surrounding the Earth. So that was dawn of space age. But I had a job. I had to go to South Pacific to observe the solar eclipse, total eclipse, and inhabited island, atoll. Soon after this, I came to Alaska. This has taken different time, but you see, I got to know those people very soon, and Chuck Dia is in the middle one. So I came to the Geophysical Institute, and director was Christian Elvey. That's my employment. Month's pay is $475. That's more than enough. And first thing I bought, if I remember, ski equipment. Then I start work with Chapman. So I showed you this before. Chapman says that when the solar gas impacts on the Earth's magnetic field, there will be a comet-shaped cavity around the Earth. So what he told me is that solar flare produce magnetic storms and aurora, but something must happen in the comet-like cavity. Then he said, it's a new generation's job. He has done enough. So whatever happened inside the comet-like cavity, some processes change solar energy to aurora and magnetic storm. That's a new generation's job. So that's the way whole thing started. So let me go to my first story of the aurora. It's called the auroral oval. The simplest way is, where can we see the aurora? And you might say, obviously, you can see it in the Fairbanks. No, the story is a little more complicated. 1860, Loomis, this must be extensive work, look at the whole newspapers all over the world, and say that aurora tend to appear more On this map, you can see pink area, and he called it auroral zone. Then I start to observe the aurora, and I found that, as you know, aurora always appear in the northern sky first, and then gradually come over Fairbanks during the course of the evening. And I thought that if I plot the auroral zone, it's a pink one over there, you should be able to see the aurora anytime. And furthermore, wouldn't come, appear in the northern sky and move towards the head. You can see so this circle is a field of view, Fairbanks. So aurora, if you're in Fairbanks, you see like this. Not pink one should be there all the time. So I thought, funny, something not quite right. Then I found a paper by Russian scientist Feldstein, and he said aurora is like this, green. So I wrote to him, I agree with him, I support you. Then he wrote me back. He had a great difficulty convincing people. Most people believed for 100 years, pink one, this is unacceptable. So I went to Moscow and discussed with him, and what I decided to help Feldstein is to set up meridian chain of all sky camera. This chain move around the Earth once a night, day. So just like airport radar scanning the sky. So at the end, I proved that this is okay. What happened then? We understand this is fixed in space, and we are moving under it, like this figure shows. Aurora is not moving on the average, but we are rotating under it. That's why it looks like the aurora move towards you in the evening. But I had a difficulty too. No one believed it. And so I went to University of Iowa. I worked with Van Allen, and we found that his radiation belt and the aurora there has this kind of geometrical relationship. Aurora coincides with radiation belt. That people start to believe what I said, but still, great deal. Once auroral zone believes in 100 years, it's very, very hard to change it. But the whole argument, controversy ended when satellite took a picture, and the north is 75 degrees. This is 65. So that's clears all the argument, no more discussion. So we have two auroral oval, north, south. This is taken picture from up Pacific Ocean. You can see Hawaii there. So that's where the Aurora oval finally people start to believe that. Of course, what I moving in the evening is a very slow. Looks like slow, but the oval actually moves quite a bit, and when the oval is small, it's sitting on the Arctic coast. You can see it from Fairbanks. It's there, and usually very quiet. So Fairbanks people say, there's no aurora tonight. That's what's happening. When medium size, then you see aurora overhead. Then it's when it becomes very active, large, it goes down to even Juneau or New York. Okay, so the auroral oval is always there. We have an invisible light to see it, X-ray, so it's almost always there. So the only thing is that it's go up and down, and the people here in Fairbanks, we don't see aurora tonight or today, and sometimes aurora go down to Juneau, we cannot see that even. So, so we start to understand a little bit the aurora. Meantime, I got married, and she's brave enough to come to Alaska. I was interested in mountain climbing, so Chuck there and Neil Davis and GI people formed the climbing club, and we did the second ascent. And I also joined the, some of you know the raft race, famous, and we got all the Navy Japanese flag from Japan. Then GI moved from Chapman Building, the old building, to new building. I think it's 1972. Before I go into a little bit more on the aurora, let me just say a few basic facts. Basic forms of aurora, however you look, it's basically curtain shape, very thin curtain, and it's developed all kinds of folds depending on the activity. And because it's a pretty large scale, it looks quite different depending on where you are with respect to the aurora. When it's overhead, it looks like that, very, actually it's a curtain. And sometimes some people thought that aurora comes from a mountain top. Well, sometimes you can see a pretty nice shape like that. That's the satellite image show. It's just a large scale fold. So it looks very different, but it's curtain. And the height is, bottom height is about 10 times as high as cruising altitude jet plane. And so 100 kilometers or 60 miles from the ground. And so space shuttle used to fly through the Aurora. And this is space shuttle flights or space station. And Aurora looks like that. And Aurora light is quite different from sunlight. It's come from atoms, molecules. So just a line, it's not continuous rainbow-like light. The reason is that, so I go to what is the cause of the aurora. One word, as a scientist, we can say aurora is an electron discharge phenomenon in space around the Earth. But you wouldn't satisfied with this explanation, so I have to go a little more. Many of you still think that sun send out charged particles, they just come into the polar region and produce the aurora. It's 100-year story, so I will give you a much more recent one. Okay, as I said, discharge, and aurora is like basic physics is the same as neon sign. You put a vacuum tube and then put a neon gas, a little bit neon gas in, and it connects both ends to high voltage supply. So what we need is power, electric power. You see this somewhere in town, right? I don't want to advertise place, but the Fairbanks airport should have this. So, as they said, in order to have the aurora, we need power. And so, next question is, where is a generator produce electric power, and how much power does it produce? During this whole period, we are working, the generator is a pretty simple machine. Looks complicated in the power plants, but basically, what you do is to rotate a coil in a magnetic field. That's the way to generate electricity. And the problem is that in rotating this, we have to use coal power, then we have a global warming and all that stuff. But basically, it's you rotate this coil in magnetic field. Corresponding to that, coil is solar wind. The sun blows out corona with a very high speed, 500, 800 kilometers per second. So it's blowing towards the Earth, all over, around the sun. Then we need magnetic field, the Earth, corresponding to this magnet. Then we found that solar magnetic field is very, very important. So we need a three ingredient: solar wind, Earth magnetic field, and the solar magnetic field. During all that period, lots of satellite launch, lots of people worked on this, and we start to learn internal structure within the comet-shaped cavity. But still that time, until about 1980, how can it produce aurora? What is internal process can make the aurora that was not known? But we found that solar magnetic field, the Earth's magnetic field, linked up at the boundary. We found this is really crucial. The reason is that solar wind blow the linked field. So so whole surface of this comet-shaped cavity is a generator. How much power? About quiet time it's 10 billion, but when aurora active, it's a very large, 100,000 billion watts. It could serve about 1/5 of whole world electricity. Yeah, so its equation is like that. You don't have to. Then the next question: what's a switch? We know the generator now, and we found that this solar magnetic field, if it points southward, it's on. If it's northward, it's off. So that's the switch. But usually, the solar magnetic field in all kinds of directions. So if it's northward, aurora is fainter. And if it's pointing southward, it's brighter. And I told you, auroral oval changes size. It's northward, it's small. Southward is large, because how much the solar field link up with the Earth's magnetic field. So if it's north, it's small, south. So we understand a little bit more. And then circuit, very complicated. I don't want to go into the generator and the aurora connected. So I worked with a Swedish astrophysicist, Elvey, quite a bit. So I said, okay, electricity, and electric current, how much current we're talking about. To do that, we had to set up meridian chain of magnetometers, Alaska, Canada, Greenland, Scandinavian, Russia. This was a big international effort. And finally we got how the electric current flow. And this blue one is called Aurora electrojet. It's about 6 million amperes. So then, of course, during the aurora, it changes. And this electric current produced magnetic field. That was my magic hand. And this operation, Jack Townsend College Observatory helped me quite a bit. poker flat was very useful in this study. It can measure the electric field and all that, and so that's. Then by then, my kids were born, and my wife had some hobby together, and took wild mountain flowers. Okay, so let me go to the third story. Auroral substorm, it's auroral activity. That aurora is not just sitting, as you know, sometimes they move around the whole sky. The question is why. And actually, this work started in 1930, it's early 30s, by a professor of University of Alaska. And this is very hard work he did. And what he finally came out was Aurora is always quiet in the evening and very active in midnight, and become disintegrated cut in patches. And then this is fixed in the sky, and the Earth rotates underneath. So that you can see active aurora, quiet aurora, active patchy aurora. Then I start to look at the camera. This is just one night. You can see quiet, active patches, quiet, 3 times in one night. So I instantly I thought Earth rotated 3 times a night. That shouldn't be. So I had to look at all sky camera from all the polar regions, start to analyze. Then what I found is that, sorry, this is a complicated figure, but you can think of a polar region way above the North Pole. This is the first satellite image of auroral activity. And so this sequence from quiet to very active and then end. This is very, so auroral activity has some systematic change. And it takes about 2 hours from here to end. And on the average, we see 6 times in 24 hours. That means in one location, you can see once, so once a night. But when it's very active, you can see twice or 3 times. So this, if you look down on the Earth from above, this pattern comes and go in 2 hours, then quiet back, then 6 hours later comes again, so like that. Only problem is that no one can stay midnight 6 hours. So that's when I said auroral activity look like that, people cannot believe it because you cannot see twice unless you have a good record. So what I have to do, one thing I have to do is to ask NASA, give me a plane so I fly from the East Coast midnight to Fairbanks. Then I can stay in the midnight. Plane speed, jet plane speed, Earth's rotation speed at this latitude is just about the same. So I can stay in midnight, so I could observe twice. And the Air Force was very much interested in so they used a KC-135 tanker plane and joined in this. Of course, many other things we have to study. This is one of the flight, kind of flight paths we did many times, but it so happens that when I was the flight, I was told that Elvey, the former director, was seriously ill. So I rushed with my films, and then I went to Tucson, and he was okay, and we sat together and looked at the film. He was the first time he trusted me. So it's very difficult. That's the way this thing is. So I have unsolved problem because it's not solved. Whole thing. For example, it's very rapid and explosive. And the satellite, fortunately at that time, Cold War days, the UFOs had a good satellite image. And it's Siberia, you can see Prudhoe Bay and the Fairbanks little. And when the Air Force got this first picture, they asked me to come to Boston to look at if that light is Aurora. They thought that Russia must be preparing new arms and something. So I had to go to Boston to make sure this is Aurora, nothing. We had many number of international conference. We had one or two in the Fairbanks. So what I have told you so far, it's a joint project. Those people, here about 120 people. So there must be 200 people working on this about Aurora. Okay. So it's just not my own. But I often disagree and give me certificates disturbing scientific community award. So there are lots of arguments still going on. So the Chapman what told us is that we begin to understand, but still new problems come. So it's new. I have to ask a new generation to take over. As you know, magnetized planets have the aurora. Very much like, surprisingly, very much like Earth's aurora. But planetary scientists want to think this is different, but I think it's about the same. I'll skip this. Meantime, I got the first PhD. We had to serve Moose family. And then It so happened that the directors, volcanologist's joke, when St. Augustine left, director changes. I hope that Augustine wouldn't blow up again. So anyway, I made an organization chart like this. Usually university organization chart, institute dangled down at the bottom. So I made my own, but staff thought that GI is like that. Very confusing. But in this confusing, I had a CPOS secretary. Someone left this picture on my desk. Here's a Helga, GI's bicycle. I'm running. Here's a faculty, graduate student, and so on and so forth. So that's about maybe staff's view. Yeah. Many things happen, but just one thing I remember is the eruption of Redoubt soon after I became director. And unfortunately, a plane from Europe got into this crowd, almost crashed on Alaska range. And of course, we told the FAA that tomorrow, very likely that Redoubt erupt. But they didn't do anything. And so that's what happened. Then I found out volcanic cloud sitting in the middle, and no department agency responsible for volcanic ash. And so we decided Institute alone can work on this. Volcanologist, seismologist, atmospheric scientists all together, and we succeeded in predicting in this Siberian volcano. This is one of the busiest air route, South Asia and North America. So we got, Al Gore gave us Hammer Award. That he meant we broke the wall of all the agencies. And another one that I had to face was, we asked the safety basis. I was asked to close Poker Flat. So I said I cannot close it because although it's a university range, but lots of people use from Air Force and everybody use it. So I had no choice but to ask Senator Stevens, funders. So he kindly gave us about $20 million to upgrade the Poker. But when they saw $20 million, they tried to take from us. So I had to protect. So, but we finally changed. It was outside and 50 below. It's now, you can launch safely. We had Thanksgiving. Yeah. My wife got the largest turkey in town, and we had the golden days. A GI director used to be target to arrest. I had a good time. So just very quickly, then Institute, they got too small, too crowded. I got to do something. So I negotiated with the Japanese government. What's happened was I went to Japan and talked to higher officials. He said, Professor, anything like this, you got Nobel Prize first. So I said, geophysics and Nobel Prize and give a prize for the geophysicist. Then he said, get Arguo's letter. In essence, he was saying, just get out of my office. So I said, I'll get it. Took 3 years to get it. Arguo wrote a very nice letter to Japan. Anyway, so to that, many people helped me, both senators and even Asahi Beer, it's the largest beer company in Japan, guided me through various routes. And I know that I didn't want to use GI money, so I negotiated with cargo airlines, and people thought that I'm in a cargo, but actually spent time in the cockpit. We had one thing that I asked my wife after I retirement, shall we live in a barrel? She said no. I asked why. She said there are no trees here. And one person I shouldn't forget is Tobac. He helped both GI, IAC Operation Barrow. We had a distinguished visitor at IAC. I think that's about it. And I take opportunity to thank UF, GI, IAC, Fairbanks people helped us. And this presentation, those people helped me to make this set of PowerPoint. Thank you.